Welcome back. In this video, we're going to talk about variables. A variable provides us with named storage that our programs can manipulate. Each variable has its own type, and the type determines the size and layout of the variable's memory, as well as the set of operations that can be applied to that variable. We're going to start off by creating a simple variable and then giving it some value so that it can represent something in our program. Now, we have our old program open, and what we can do is just highlight this command here and delete it. Now, to declare a new variable, all we have to do is type the variable's type followed by the variable's name. I'm going to call this one my character. Now, the type of this variable is the char data type. Char is short for character, and a character is a single symbol such as those you see on your keyboard. Now, this line declares a variable of type char, meaning we set aside some memory for this variable. But the variable has no meaningful value assigned to it. When you declare a variable, what happens is whatever's in the memory from the previous program is left over. In other words, this variable contains garbage data, and we need to overwrite that. So in order to initialize my variable called my character, on the next line, I'm simply going to write my character equals y in single quotes. Now, a character is in single quotes. The single quotes denote a character. If I put double quotes, what this symbolizes is a string of characters, such as the string pause in the system command down here. So the equal sign is known as the assignment operator, and what it does is it takes something on the right side and assigns that value to the variable on the left side. So it takes two inputs, some value to the right and some variable to the left. And what it does is gives that value to the variable. So now the storage set aside for this char variable contains y, which is one character. Now a variable of the char data type can only hold a single character. It cannot hold more than one because it does not have enough storage for more than one character. Let's move on to another data type. Now, go down a couple lines and let's declare another variable. This time we're going to type int myInt. An int is short for integer, and an integer is a whole number which can be positive or negative. So in order to initialize myInt, we do the same thing that we did with myCharacter. Namely, we type myInt, use the assignment operator, and give it some integer, such as 13. Now what we can do is use the cout command to print this text to the screen. Now I'm going to show you a trick that we didn't use in the first video, and that has to do with when you're using namespaces. Recall that to print text to the screen, we had to use the cout command, but we had to reference the standard namespace with the std followed by the double colons before we can use the cout command. Now, if we know we're going to be using commands from the standard namespace, then we can actually come up to the top under our include statement, and we can use the following. Using namespace standard. What this line does is says we would like to use the standard namespace, and so anything inside the standard namespace, such as cout, doesn't have to be prefixed with std. Now, if we wish to use the cout command in order to output the value of some variable, all we need to do is use the name of the variable. For example, to print out the value of my character, we simply use cout with the shift operator and type my character. Now, because we want a new line and my character isn't in double quotes, which the /n operator needs to be in double quotes, we can append to this output using this operator a second time, and we can type the double quotes with the /n. This will give us our new line character. Now, rather than go through all this trouble, we can take advantage of something else that's in the standard namespace, and that is the ENDL, or end line. End line doesn't require double quotes because it's not a string of characters, but it's rather a name that we access from the standard namespace. So if we didn't have this line up here on line 2, for example, if we deleted it, then not only would we have to prefix cout with std::, but we'd also have to prefix endline with std::, as well. So endline is convenient because we don't have to type double quotes with the /n inside. Endline is equivalent to doing the same thing. Now, on the next line, let's cout the myInt variable. So what this should do is cout the variable of my character, which is simply y. And then on the next line, we should cout the value of the variable myInt, which is 13. So go ahead and hit save, and we'll use the hotkey Control F5 in order to compile. As you can see, we've printed out my character, which is equal to y, and printed out myInt, which is equal to 13. Now, variables can be overwritten, which is really what we did when we initialized them with values. You see, as I stated earlier, the variables are actually filled with garbage data left over in that memory space from the previous program. Well, when we initialize the variable, we're really overwriting that data. We can also overwrite the data that we put into the variable by simply assigning it with a new character. So to assign a new value to my character, simply type my character equals, and now we can give it a new value such as the character n. Likewise, we can give myInt some new value as well. Now if we come up here and copy these two lines and paste them just under myInt, if we hit save and Control F5, now we get the new values for our variables, namely n and 12. So variables can be initialized and they can also be overwritten. Now, a myCharacter variable cannot take on a number that an integer can take on because myCharacter and myInt are different data types. So what's all this talk about data types? So far, we've actually declared a variable of type char and initialized it with some character value, but what is the difference between a char and an int, and how many other data types are there? Well, data types can be classified in 3 main categories. These categories are integral data types, floating point data types, and the void data type. Now the void data type describes a set of empty values, and no variable of type void can be specified. Void data types are mainly used to describe the return type for functions that don't return anything. But we'll talk more about functions in the future. For now, let's talk about the integral and the floating point data types. The integer is probably the most common of the integral data types. Typically an integer requires 4 bytes of storage, and if your number is larger than 4 bytes, then you won't be able to store it in an int. Now there's an integer which is smaller than 4 bytes, and it's known as the short int, or sometimes just called short. Now the short int can be used if you know your number is going to be very small and you're not going to require anything close to 4 bytes. Likewise, there's a long int, and if you know your number is going to be larger than 4 bytes, you may wish to use a long. Some other types of integral data types are the char, which we're familiar with, and the bool, which is a true or false value. The char and the bool require 1 byte of storage. Now let's talk about floating point data types. Floating point data types consist of an integer component as well as a fractional component, which is represented by numbers to the right of a decimal point. Now, the reason it's called a floating point data type is because when you take a number and give it to the computer converts it into a scientific notation representation of that number. What I mean is, take the number 7,289. We see that as 7289, but the computer converts it to 7.289 times 10 to the third power. In other words, it says, take this number 7,289 and represent it as a single integer with a fractional component times 10 to some power. And it's often referred to as 7.289 E3, and the E3 just means times 10 to the third. And if you actually create some floating point data type and use this notation with the lowercase e, the computer will know what you mean. So when the computer takes 7289 and converts it to 7.289 E3, what happens to the decimal point is it floats from the right side of the 9 all the way over to here between the 2 and the 7. So because the decimal floats over from the 9 over to the 7, this is the reason why floating point became the name for floating point data types. Now the float is the smallest floating point data type. It's 4 bytes typically, and if your number consists of something larger than 4 bytes of storage, you may wish to use something larger. The double is larger than the float, and it's typically twice the size of the float, so it's typically around 8 bytes, and that's why it's called double. If you're using something larger than a double, which is probably quite a large number, there's something called a long double, but for our purposes, we're probably not going to be using something that big. In fact, for game development, we're going to be throwing around numbers around the size of a float. So what I would do, if I were you, is not get overwhelmed by all these different types of data types. Just keep the core ones in mind that we're probably going to be using most often. And those include the integer, the boolean, the char, and then when it comes to floating points, we're mostly going to probably just use floats, and maybe double if we require that much precision, but for our purposes, it's probably going to be overkill. So these are the data types, and keep those core data types in mind when we do our programming assignments.